Okay, so we have 11.1 simple interest. So we have our simple interest formula is I equal to P RT. Oh, right there, R a little better. So that's P times R times T. And that is our simple interest formula. So I represents your interest earned. P is your principal, which is your deposit or your loan. R is your rate, in which you will convert that to a decimal before you do your calculation. And then T is your time, which is in years unless otherwise stated. All right, let's scroll up. All right, so first problem, calculate the simple interest earned in 1 year on a deposit of $1,000 if the interest rate is 5%. So I always suggest that whenever doing any type of word problem that you would write down all of your given information first. So our deposit is $1,000, that's our P. Our rate is 5%, convert that to a decimal is 0.05, and our time is 1 year. All right, let's scroll up. All right, so you just do P times R times T. So that's 1,000 times 0.05 times 1, which will give us 50. So that would be $50 interest. All right. Any questions before we look at another one? All right. So the next one, calculate simple interest. Calculate the simple interest due on a 3-month loan of $2,000 if the interest rate is 6.5%. So this time we have a 3-month loan and it's not given to us in years. So we have to convert it to years. And before we do that, I'll let you guys finish writing, just make sure everybody's together. But we want to convert that to years before we plug it into our formula. All right. So we had 24 months and we want to convert that to years. You know, that's 24 months is 2 years. The reason why you would find that out is because you would divide that 24 by 12. So you keep that same energy when it comes to anything that deals with months. So if it's 17 months, you would put that 17 over 12. Same thing with weeks. There are 52 weeks in a year. So if you have 19 weeks, you put that over 52. And then the only thing you may have to remember or hold on to is that if you're dealing with days, you have to do 360, and that's instead of 365, and that's because of Banker's rule. You know, some say that they're use a 360 just because that's an even more even number than 365. Then I also read somewhere where they said there are five, legit holidays that they recognize. So that's why they took the five off of 365. But either way, we're going to use 360 for days. So if you ever have something or measurement other than years in your time, you do need to convert it. All right, questions on the conversion? So if we write down our givens, P is 2,000 for our deposit. Was it a deposit or a loan? It was a loan. So $2,000 loan, 6.5% is 0.065. And then our months, it's going to be, we have 3 months, so that'd be 3 over 12 as far as years are concerned. All right. Questions? Any questions?
I do have a really quick question.
Mm-hmm.
Will we always be required to convert like months or anything into a fraction, or can we use decimals?
You should be able to use decimals. Decimals should be fine. Now you have to be careful though, because if you have 1/3 of a year, what you don't want to do, because that's a run-on decimal,
Right.
you don't want to write zero point 0.3 and use that because you won't get the most accurate answer. So in that type of case, you do want to use 1/3, because that's a great question. 3/4, I mean, not 3/4, 3/12 would be 1/4, which is just 0.25. So you wouldn't have a problem here because there's a terminal decimal. But if you have a run-on decimal, it would be best to use a fraction.
Okay. Thank you.
That's not a problem. Like I said, that was a good question. Good question. So take that 2,000, multiply it times 0.065 times the 3/12, or 0.25. That will give you that 3250 as your interest. All right. Any questions? Any questions? So now this is one of the ones. Remember I mentioned, and these are few. You will see these. There'll only be a few of these that you may see in your examples. Maybe only one, but you do have to make sure you're careful. Here, calculate the simple interest due on a 2-month loan of $500 if the interest rate is 1.5% per month. So if it says per month, then you don't have to convert it if it's in months. Everything else was dealt in years, your percentages, APR, annual percentage rate, and you're always going to assume that you're in year unless you see that the rate is per another term, like I said, per month. Then you are good with leaving this thing as just 2 months. All right. So make sure we're careful with that. When we go back, it just talks about our percentage rate. It doesn't say per anything, because if you just see a percentage rate, they assume you are in years. So this APR, annual percentage rate. Only time you will look at that percentage rate differently is if it says something different. So in this case, calculate the simple interest due on a 2-month loan of $500 if the interest rate is 1.5% per month. So that means I can leave this 2 months as 2 because we're looking at the percentage rate per month. And we can go ahead and write it as such. And I don't know if I gave you guys enough time to write that. We come back up. So, but make sure we're careful with what we see and how we will handle it. Like I said, a lot of these, there are only maybe one or two of these that you will see, but it's always about what follows your percentage. If it says per month in your percentage, that's what you're dealing with. If you don't see anything, you're dealing with years. All right, so that 500 times 0.015 times 2 is 15. All right, anybody holding on to that? All right, here we have another one. Calculate the simple interest due on a 45-day loan of $3,500 if the annual interest rate is 8%. Once again, you don't see anything back here, so we're dealing with years, so we're back to what we were doing before, in which you have to convert that 45-day to years. All right, so P is 3,500. Our rate is 8%, which is 0.08. 45 days is our time, so we place that over 360. So in order to calculate that annual interest rate, multiply those three things together, get $35. Not the annual interest rate, the annual interest earned. I say annual interest rate, calculate annual interest earned, and it'd be $35. Multiplying those together. All right. Any problems before we look at future value? All right. So the next thing, future value, A is going to represent your future value or maturity value. Those are the same things. They're used synonymously. So they could ask you for the future value or they could ask you for the maturity value. That means the same thing. Both of those are A. So you can either, if you've already calculated your interest, all you would do is take that interest, add it to your principal. That would be the future value or the amount of money that's in the account, after however many years or whatever. Or if you haven't already calculated the interest, you can use this formula here, P times 1 plus RT, and that will give you that same future value. So like I mentioned, A represents your future value or maturity value, and all of your other variables are going to be the same thing. P is your principal, R is your rate, T is your time. And then in the red, I was just reemphasizing what A represented, the total amount of money in an account or is owed after T years. All right. Calculate the maturity value of the simple interest 8-month loan of $8,000 if the interest rate is 9.75%. So P is 8,000, R is 9.75, which is 0.0975. Then we have 8 months, which converting that to years is 8 over 12. I think I did both ways, but we'll go here. So in this case, what I decided to do was calculate the interest separately. Let me see if the interest rate, simple interest, yeah. I just calculated interest separately, took 8,000 times 0.097 times 8 over 12 and got 520. Now to find your maturity value, add that 520 to your principal and you get 8520. All right, any questions? Any questions? So I found this one by first finding the interest, then adding it to the principal. I think the other way. Yep. And so the next one I'm going to do the other way just to show you that it'll work either way. So here, calculate the maturity value of the simple interest 3-month loan of $3,800. The interest rate is 6%. All right. 3,800 is our principal, 6% is our rate. 3 months is 3 over 12. So we can plug into this formula. P times 1 plus RT. So put that that box around there. Probably was telling the class that you could just put that in the calculator. If you have a calculator, just put it in there. If not, 0.06 times 3/12 give you 0.015. 1 plus 0.015 is 1.015, and then multiply that times 3,800 is 3857. Or like I mentioned before, you could have done it the way we did it in the last problem, where you calculate your interest first and then just add it to the 3,800. Either way, you get the same result. Any questions? Scroll up. Here I was just pointing out in the purple, just pointing out that if you ever needed to find interest, let's say if they ask you how much interest was earned, then you always can take your maturity value or future value, subtract the principal, your original amount, and that will give you the interest earned. So they didn't ask it in this problem, I don't believe, but that's always something that you can do if they were to ask you how much interest was earned. If you have your future value and then you have your principal, you can just subtract those two values. That'll tell you how much it was earned during that time period. All right, let's see. I think this is the last one out of this section. Just checking. Yep. All right, so one more out of this section. Everybody good before we go to it? All right, here we have the maturity value of a 3-month loan is $4,000. 3 months loan of $4,000 is $4,085. What is the simple interest rate? So this time they give us the future value, they give us the principal, they give us the time, but they do not give us the rate. They want us to find out the rate. So in the purple is what we had. That's our given information. We have our maturity value, which is A, principal, which is P, T is time, and then we are looking for R. All right. One way of doing it is that you can subtract A and P from each other to find what I is, your interest earned. In this case, it'll be $85. My pen. 4,085 minus 4,000 is 85. Then you can take I equal to PRT, plug in the values that we do know, and calculate or solve for the value that we do not know. So we have 85 equal to 4,000 times R times 3/12. Went ahead and multiplied these two together. And that's how I got 1,000. So 4,000 times 3/12 will give us 1,000. And we can divide both sides by 1,000 to get R. And that'll be our answer. Either 0.085, or if they want it in percent form, move your decimal 2 places to the right. That'd be 8.5. All right, questions? Any questions? All right. Let me see. All right. So let's look at 11.2. Very similar to 11.1. So we're looking at compound interest. So for loans more than 1 year, the interest paid on the money borrowed is called compound interest. The frequency with which the interest is compounded is called the compounding periods. So you're talking about the frequency in which your money is hit with interest fees, or way to calculate your interest. All right. So now we'll warn you that for this formula, you will need a calculator, a scientific calculator at least, because we have this exponent right here that may be a little problematic if you want to do this by hand. So compound amount formula is how the book said it, but compound interest formula. No, this one's for the amount. Right. So these variables are still going to hold true to what we talked about in the last section. A is the future value. P is your principal. R is your rate. Now, N is a new one for us. We'll talk about that one in a second, but T is your time. So that's A equal to P times 1 plus R over N raised to the N times T power. So N times T right here is the exponent. All right. So now N is going to be the number of compounding periods per year. So just like when everything else, they're going to tell us all of that to plug in. And if you have any troubles with using your calculator, always feel free to get with me on that. There are videos, if you just YouTube, your calculator. Most calculators have a YouTube video on how to use them. But of course, you don't have to go to that. You can always ask me. I'll do whatever I can to help you out. Now, so what they're going to do when it comes to this compounding periods are N. They're going to give us a key word that's going to let us know what N is supposed to be numerically. All right. So in the purple is what we're talking about there. So annually means that N will be 1 year. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. Daily, N is 360. Don't forget, we're talking about banker's rule. And I think you guys may not have continuous compounding. I'll have to see. This we'll see as we go up. So if you see anything about continuous compounding, it's different than daily. But I don't think you guys have that. Sure. All right, so let's look at the next one. Yeah, you guys don't have a continuous compounding formula, so you don't have to worry about it. So let's look at this first one. Calculate the compound amount when 10,000 is deposited in an account, earning 8% interest, compounded semi-annually for 4 years. All right. So 10,000 is going to be our P. 8% is R. 4 years. And since it's compounding semi-annually, that means N is going to be 2. All right, so plug it into the formula. Now, once again, right here, I mean, if you have the calculator, you can just plug it into the calculator just like this. And that'll be all you need to do. But if not, you have to do it in pieces. You know, 2 times 4 is 8. Dividing this 0.08 by 2 will give you 0.04. Add those together and then multiply by 10,000. So once again, it would be more beneficial for you to be able to do this in your calculator, cut down on steps, and prevent some mistakes. But if not, then you have to do it in steps. All right. Questions? Any questions? So both of these sections, 11.1 and 11.2, are really about using the formulas and plugging them in properly, plugging in the numbers properly. Let's scroll up. All right. So the next one, how much interest is earned? Let me write that earned better. In 2 years on $4,000 deposited in an account paying 6% interest compounded quarterly. So notice it asks us how much interest is earned in 2 years on $4,000 deposited in an account paying 6% interest compounded quarterly. So as always, you write down your given information first.
I'm sorry, could I just see the answer for the last problem to make sure I got the right answer?
Sure.
That's the answer?
You're right here.
Yeah.
13. Yep.
So it wasn't 43,264.
Should have been.
Nope.
Yeah.
And you said we can plug this into our calculator, right?
Yeah, if you plug it in just like this right here.
Yeah, that's the answer I'm getting when I plug it into my calculator. 43,264.
All right, so what about right here, your parentheses? You have parentheses on both of these?
On the exponent I should have parentheses?
Yes. You should have to write it exactly the way I wrote it. Yep.
Okay, my bad for holding you up.
No, you're fine. It's all right. We don't have much left anyway, so you'll be good.
Parentheses 2 times 4, close parentheses. Okay, yeah. Okay, thank
Cool.
you.
Not a problem. So here we're looking for how much interest is earned in 2 years. $4,000 deposited in an account paying 6% interest compounded quarterly. And so we have P being 4,000, R being 6%, 2 years, and compounded quarterly means that N is 4. All right, let's scroll up. All right, so what we're going to do is take this information and find out the future value first. Remember, we want to know the interest earned, but we need to find out future value. So we plug in our values accordingly. That'll give us 4505.97. Putting this in the calculator. And then we're leaning on that relationship of taking our future value minus our deposit or our principal, our initial principal. So subtract those two from each other. That'll give us 505.97. 555. I said 555. $505.97. All right. Questions? Any questions? All right. So they also give us a present value formula. Basically, the way to calculate your principal with those same information. And if you look at this is just the last formula that we had, but it's solved for P. So it's the same formula, it's just that they have P over here instead of A. So they solved the formula for P. All right, so how much money should be invested in an account that earns 8% interest compounded quarterly in order to have $3,000 in 5 years? So we want to know how much money we're going to invest. In other words, how much should we have initially in order to have $30,000 in 5 years? All right, so once again, we write down our given information and what, letters they are assigned to. So the 30,000 is our A, that's our future value. That's the amount of money we want to have after 5 years. The interest rate is 8%. Like I just mentioned, the time is 5 years. And it's compounded quarterly, so N is going to be 4. So once again, that's how you will plug it into, right here's how you will plug it into your calculator in order to get this answer right here. Once again, you want to make sure you're efficient with your calculator. Slash right here is your division sign. So it's 30,000 divided by. So you have to use those parentheses to ensure that all of that is in your denominator and stays in your denominator. So it's 1 plus 0.08 divided by 4. And this raises it to the 4 times 5 power. So you have to at least have $20,000, $20,189.14 in your account in order to earn $30,000 in those 5 years. All right, any questions? About I think like one more formula to talk about. So here, inflation. So I was going to say inflation. So inflation is an economic condition during which there are increases in the cost of goods and services. So suppose your annual salary today is $35,000. You want to know what an equivalent salary will be in 20 years. Assume a 6% inflation rate. Okay, so 35,000 is our P, zero point zero 0.06 is R, 20 years is T, and inflation rate is annual. So we're going to let N be equal to 1. And we plug it into the formula. So we get $112,249.74 would be what it would increase to. Any questions? I believe this is our last one. Gonna scroll up. Pretty good. All right. So effective interest rate, a simple interest rate that would yield the same amount of interest after 1 year. All right. So a credit union offers a certificate of deposit, COD, at an annual interest rate of 3%, compounded monthly. Find the effective rate. Round to the nearest hundredth of a percent.
Can you scroll up just a little?
That good enough?
Yeah, I'm fine. Thank you.
Mm-hmm. All right. Okay. So once again, we have a credit union offering a certificate of deposit at an annual interest rate of 3%, compounded monthly. Find the effective rate and then round to the nearest hundredth of a percent. All right. So we're looking for the effective rate. So we're going to let P be equal to 100. And we have this 3%. And we're talking about within a year. And told us that our interest rate was compounded monthly. So once we have our values established, we can go ahead and plug it into the formula. Something real quick. All right. So throw it into the calculator. That's the future value. If you were to deposit $100. All right. So find the interest earned. It's A minus P, 103.04 minus 100. And the effective interest rate is going to be 3.04%. So that's the way we would be able to calculate that. Like I said, you use 100. That will give us the outcome that we need. Use 100 for P. All right, questions. All right. That's it for 11.2. That was something else I got it. So that's it for 11.2. Next class will be a review day because 10.1, I think I wrote it down here. Yep. 10.1 through 10.3, not 10.2. So our next block of work that's going to be due is 10.1 through 10.3 at 11.1, 11.2. So next class, we will not do anything new. It will be set aside for any questions that you guys may have on anything. All right. So I know I had one of your classmates had a question or two on something that she had asked about through email. Anybody before I go there, did anybody else have any questions on anything that was said on today? All right. So once again, next class will be a review day, and we'll sit back, talk about, see if anybody have any questions on anything. So you most definitely bring those questions on next class. So let's look at now. I forgot your name. I apologize. Your questions that we're supposed to be addressing today.
It's Anaya.
Yep, there you go. I appreciate it. Thanks. So did you have those questions already pulled up, or you needed
Oh,
me to look them
yes.
up? Okay. All right. So what you got?
It was y equals x plus 4 when x equals -5, -3, 0, 3, and 5.
Okay, got you. -5, -3, 0, 3, and 5. You had those, right? Now, wasn't the absolute value over these? Wasn't that your problem? You had those bars
Yes.
on? Okay, right. Okay, so just make sure we okay with the first part of the actual application of those absolute value symbols. The absolute value of anything is going to be the positive result. So if I have the absolute value of -3, the result is 3. If I have the absolute value of -3, the result is still going to be 3. If I have the absolute value of -7/10, the result is going to be positive 7/10. If I have the absolute value of 0.75, well, the result is 0.75. So those long bars, and this is for everybody, just in case anybody may have forgotten or didn't know, those long bars will always yield a positive result. So what we're going to do is they give us these 5 values: -5, -3, 0, and positive, 0, +3, and +5. So we're going to plug those in for x and find the corresponding y value. So you have -5 plus 4 inside the absolute value. So that'll be -1. Absolute value of -1 is +1. So when x is -5, y is +1. Do the same thing for -3. -3 plus 4 is +1. Absolute value of +1 is, once again, is +1. Zero plus 4. Absolute value of 4 is 4. That gives us 7. When you plug in 3 and then plugging in 9. I said plugging in 9, plugging in 5. I'll move ahead. Will give you 9. So before we go any further, is everybody okay with what happened? So you took each one of those values that they gave, -5, -3, 0, +3, and +5, plug them in, calculate what's on the inside of the absolute value first, then apply the absolute value, which should always give you the positive representation of that number. Now, Ms. Brackett, did they ask us to graph that?
Yes.
Okay. So just rewriting a chart here, XY chart. So just making sure I got my numbers right. So we got 1, 1, 4, 7, 9. So that's what we're looking at. These are our ordered pairs that we're going to graph. All right, so we graph each one of those points. Go to the left 5, up 1. Left 3, up 1. 0, so we don't move left or right, but go up 4. Left 3, up 7. And left 5, up 9. So you should get a V. So whenever you do absolute value equations, you should get a V. Now how far that V goes down, of course, will depend on that value. You have to find the value. Let's see. Well, I ain't worried about it. But anyway, it should be a V shape. All right. Miss Brackett, is that okay?
Yes, I had the right answers, but I didn't take the negative off of it, I guess.
Yeah, okay. Yeah, that'll do it. Yep. Did you have another one outside of that, or was that the only one?
No, that was the only one for right now.
Okay, cool. So, just like I mentioned, just want to reiterate the fact that next class will be a review day. I will not do anything new on next class. Feel free to bring whatever questions you guys may have on next class, and we'll knock them out. All right. Any other questions before we close today?
No.
All right. So you guys have a good one. Be safe, and I'll see you next class.
You too.
Thank you.
Thanks. Thank you. You too. Thank you.